In this video, I'm going to show you how you can make your very own DIY custom kayak trolling motor mount that's cheap, lightweight and strong. Let's get into it. I've just measured the overall length that I want. I have 150 mils sticking outside the kayak, which is just enough to clear the prop as it comes up, or 6 inches. So it makes the overall length 850 mils, and I just use a square to help me line it up on the saw. Let's give it a cut. Very important to not forget your protective eyewear and earplugs when you're cutting. Now you can use a standard drop saw. You don't need a metal drop saw for aluminium, it'll cut through just fine. Double check your measurements. Also, don't forget to clean up your work area. These aluminium shavings are very sharp. I'm going to mark out 150 mils. Double check my measurements, bang on, and I'm going to cut this side of it. Perfect. Now I'm going to use the piece that we just cut off to mark the next one so that they're equal distance, making sure that it's flush on this side, which it is, and I'll make sure that I cut on this side of the line again. There we go, 2 even straight cuts right there, ready to go. So as you can see, this 32mm by 32mm aluminium tube is perfect for the NextGen 10 Mark II's profile in here. But what you have to watch out for is that these holes aren't always centered in this profile here. So you need to use a pair of verniers and measure the distance of the center of the hole to the side of the profile there so it sits nice and flush. So we're looking at about approximately 12 millimeters from the outside edge to the center of the hole. Next, you want to make sure that you have your aluminium tube approximately where you want it to be drilled, and you want to use your verniers. This is the easiest way, set at that 12 mil mark to make a score line. There we go, and that'll help me determine exactly where I need to drill. Repeat the process on the other side. Just give it a measure. Checking on this side, we can see that the distance between the center of the hole to that edge of the profile is a little bit larger than 12 millimeters. It's almost 14 mils, so just double check either side before you score your lines and drill your holes. So you can use your verniers to score along and give it a mark along here as well. Once you've scored your line, make sure you're happy with how far it's protruding either side, and all you have to do is make a small mark with a lead pencil, and then measure the distance between the center line and that mark that you've just made. So we're looking at about 32 millimeters. So at 32 mils, I'm going to make another score along here, and there we go. We have our center line, which is right there. I'm going to go drill that hole now. So I have a drill press here, and I'm going to take advantage of it. If you don't have a drill press, you can use a hand drill, but just make sure that you're drilling accurately. I would advise that you mark on the bottom side and the top side and drill 2 holes instead of just going straight through, to make sure that it's going to be a straight centered hole. So I'm going to use a 2mm drill bit just to drill a pilot hole. It's probably not necessary, but it's always good practice. And don't forget your safety glasses. Just swapped over to my 6mm drill bit now, which will match the hole size, and align it up with my pilot hole. So on this side, it's going to be more difficult to figure out exactly where the hole has to go because it overhangs so far. So what we're going to do is line up the center holes and draw a mark so that we can see exactly where the hole is, and then transfer that onto our aluminium. Now we've made that mark, I'm going to line it up as best I can from above using the square. If need be, we can oversize this hole here if we didn't get it quite bang on. So let's give it a shot. So on this next step, I'm going to show you 2 ways you could do it, an easy way and a slightly harder way. The first way is you would use your verniers here, measure the width of the material, in this case it's 32 millimeters, find 16 millimeters and score a straight line all the way across, and then come in with say a ruler, or again use the verniers on the outside edge, just score your exact center lines for your holes, and do that on all 3 pieces. But I've come up with a slightly easier way that I'm hoping will keep the holes perfectly centered for all three pieces so that the bolts go in, and that is using this 3D printed hole spacer I just made up. So this perfectly fits on top, and I'm going to hopefully be able to use the drill press and get it going straight down on each one, and everything lines up nice and square. And there we go, we've just drilled out 3 sets of holes. And there we go. Looking pretty decent. Alright, I've got a couple of cheap chopping boards from the $2 shop. This is just going to be a bit of a sacrificial board for when we tighten up the trolling motor to that new bracket that we've made, that it doesn't tighten into the aluminium too much, and we can easily replace these in the future if need be, if they get pretty messed up. So all I've done is measured 96 mils and scored it with the verniers, which is exactly the height of the bracket that I've made, and we know it's 150 mils long. So I'm going to go scribe all that out now, and I'll cut it up and we'll be back when I'm done. And there we go, we've got our 2 sacrificial boards, 150 by 96 mil, and I'm going to do the plastic ones as well. So as you can see, I've printed out another template here. It's basically cheating, but I've got a 3D printer, so I'm going to use it. I've got 4 mil holes here. I'm going to just drill pilot holes first, and I'm going to do it on either side, and then I'm going to drill them out to 6 mil, and hopefully the holes line up a lot straighter. It's a lot easier than me taking this whole bracket out, trying to line it up on the drill press, because I'd have to sort of balance it, because the platform on the drill press isn't very large. So let's give this a go. Worked out pretty well. Now we'll do the other side. After I've drilled out the 4mm pilot hole with the 3D printed bracket, I've come along with a 6mm drill bit, and I've enlarged all the holes ready for my 6mm bolts. Next, I'm going to use the same 3D printed mount that I used to drill the pilot holes on the motor mount to drill the pilot holes into this sacrificial board. If you don't have the 3D printed bracket, then you use verniers using the exact same measurements you use to scribe on your motor mount. Transfer those sizes onto your sacrificial board here on either side. Wherever they intersect is going to be exactly your center point to drill. So I've drilled out both the timber and the nylon cutting boards now with the template. Now we're ready to bolt it all together. Here I'm using nyloc nuts, stop them from vibrating loose. There we have it, completely assembled. All that's left to do is to install your trolling motor, get out on the water and have some fun. In the next video, I'll show you the trolling motor in operation along with the mount and how it holds up, and give you my thoughts on the Water Snake T24S. Until then guys, take it easy.